that I'm delighted to introduce on behalf of Selkie and Language at Leeds, Professor Ian Maddieson, who's adjunct research professor at the University of New Mexico. I won't give you your full title. And Professor Emeritus at the University of California. Ian has worked on phonetic typology, phonetics and phonology of hundreds of languages. He's currently working on a project to look at environmental effects on the phonetics, mainly the phonetics of language, across 1,000 languages. That is 1/7 of the languages spoken on the globe, which I think is extraordinary. You've also conducted fieldwork that you do, at the moment you do mainly library research. Before I make any more mess up of this, I would like to introduce you to speak. Thank you very much.
Okay, thank you very much for the invitation to come here, and thank you for coming to attend, and for the people online, thank you also for your interest. So I am going to talk about what accounts for the distribution of an idea about what accounts for the distribution geographically of tone languages. And as an aside, I'm going to talk also about how frequent it is to have languages that are tonal, since there's something of a discussion about this, mainly started by me. This is actually a continuation of research that began in about 2011, 2012 with Prof. Coupé, then at the DDL in Lyon, in France, now in Hong Kong, and more recently with my colleague at UNM, Carl Benedict, and we've reported on our ongoing project in a paper that appeared last year. So where's our starting point? It's been observed quite frequently that tone languages tend to be spoken essentially in warmer and more humid areas, or people may express it by saying near the equator, but not in deserts. Note. So this is a map of the 1,000 language sample that Janet mentioned, where tone languages are found within that sample. And the red triangles that show up most prominently are languages with complex tone systems, that is, more than 3 different tonal categories in their tone system. The crosses are 3 tone systems, high, mid, low in most cases, and circles, blue circles that are a bit hard to spot because they don't contrast that much, are languages with simple tone systems. And there's quite a few of those, particularly in the northwest of North America. So that's kind of a starting point as to where you find tone languages. So the question is it something that's fairly accidental, or is there something in the environment that is directing tone languages to occur more in this part of the world than elsewhere? And this idea that languages might be shaped, the phonetic structure of languages might be shaped by where they're spoken, is quite an old idea. I mean, you can find references to this sort of thinking, at least in the 17th century literature, when people first began talking, well, no, Plato had some things to say. But when you get a lot of more serious discussion about language and structure coming into at least English literature. Now, I put up a little quote here translated from Paul Passy, who was basically the co-founder of the International Phonetic Association. And he said, among outside factors, one is first of all tempted to attribute a big influence to the climate. It seemed natural to think, for example, the vocal folds will vibrate better vibrate better and more easily in a warm climate than in a cold climate. This is kind of an idea that's been taken up again fairly recently. And it's also possible that cold, wet climates lead to opening the mouth very little. This was Paul Passy in his dissertation thesis, Les changements phonétiques. And there's a footnote to this page where he says, the English don't dare to open their mouths for fear of breathing in the fog of their land, which I'm not sure how seriously he meant. Now, recent work by Caleb Everett and colleagues suggested that the distribution of tone language is a function of variation in the humidity of the environment in which they're spoken. The reasoning being as follows: low humidity leads to desiccation of the vocal folds. Desiccated vocal folds make precise pitch control more difficult than when you have moist vocal folds. Therefore, tone is avoided in languages that are spoken in areas with low humidity. And a couple of papers that go into this in some detail. And they add, this hypothesis does not predict that languages should necessarily trend diachronically towards complex. They're particularly talking about complex tone systems in warm and humid regions, but merely predicts that languages should be more likely to lose or never acquire that phonological feature if they're spoken in very cold or otherwise arid regions over a significant although undetermined time period. And then also complex tone, and to a lesser extent all phonemic tone, requiring comparably precise manipulation of fundamental frequency, should be disfavored in extremely arid contexts. We predict as well this tendency should be particularly apparent in frigid climates, given the extremely reduced water vapor capacity of cold air. So they illustrate this point with statistical tests, of course, but also graphically, and this is easier to follow. So the complex tone, red dots, blue dots, or anything else, versus the mean specific humidity. So lighter shading, higher humidity, darker areas, low humidity, and you can see that the complex tone systems do mainly appear where it's light shaded. Then this graph shows where those languages with complex tone occur in relation to mean annual temperature, which is what I'm going to emphasize later on. So the lighter shading here means warmer mean temperature, and the darker shades are colder areas where they're predicting darker tone. But note that what they have provided is a rationale for the loss of tone in dry areas, or the absence of tone in dry areas, not for the presence in warm areas. Moreover, they suggest that the main mechanism for spread of complex tone is lexical borrowing, not internal development. So they don't actually have a story as to why tone is an adaptation to high humidity. They have an explanation that they offer for its absence with low humidity. Because I think what we need to look for is an explanation of why tone develops in certain areas more than in others, not an explanation for its absence. When you think about it, this idea that there's a loss of tone in dry areas implies that tone is thought to be more widely distributed at some earlier point. And slight discussion here. It's often asserted that most modern spoken languages are tonal. And some people therefore take this as an indication that the original human language was tonal. A couple of quotes from a paper by Stephen Brown. It says, first of all, the majority of spoken languages in the world today are lexical. Lexical tone is the ancestral state of spoken language, and the loss of tone is a derived feature of non-tone languages rather than the reverse progression. Is there support for these assertions? Can we in fact reach a better idea of how many languages are tonal? And does what we know about language history support the idea that tone might be original? And is there any evidence of tone loss in cold, dry areas? In fact, it's frequently asserted that tone languages are globally predominant. You find this repeated in many popular information sources like Wikipedia. Here's some quotes from various Wikipedia sites, which are not translations of each other, but independently written ones. So the first one in Czech says tone languages are prevalent. Then from the German one, tone languages are the most common. In French, the majority of languages are tonal. In Indonesian, about 70% of languages tonal, and in Frisian, more than 70% of languages are tonal. You find similar kinds of assertions in a lot of textbooks and teaching materials and articles. So Clark and Yelp say most of the world's languages are in fact tonal. Tones are employed in 60 to 70% of the world's languages, more than half, the approximately 7,000. Around 2/3 of languages, the majority of spoken languages, and so on. Where do these assertions come from? In almost all of these cases, there is no citation given as to where that conclusion comes from. If there is, it's often from this textbook, which Maria telling. And she says, although those of us whose first language is English think of tone as exotic, it is in fact extremely widespread. What people often don't pay attention to is the next sentence. At a very rough estimate, as many as 60 to 70% of books, languages may be tonal. I wanted to get a more precise idea of whether this was true, and also to what extent this might influence our opinion of that claim that human language was originally tonal. So I looked at the ethnologue listing of what they consider current or recently spoken languages, and there are 7,281 of them. I limited the study to language families that have 20 or more members, which captures 6,520 of those languages, which is almost 90%. So we're not missing a huge number. And then I used two different strategies to try to estimate how many of the languages in that set were in fact tone languages. And you can often find a description of the entire family, which says, you know, this language family has no tone languages, or all the languages in this family are tone, or whatever. And where I couldn't find a description of the ensemble of the language family, I would do a sampling based on the subset. So let's explain a couple of those. For example, family language summaries. There's a well-known paper by Michael Cross where he discusses the Athabascan language family. there are two non-Athabascan languages related to Athabascan, Eyak and Tlingit. And Tlingit is tonal, Eyak is not. And there are 28 of the 44 languages that are in this family in the Athabascan are tonal, and that equals 64% when you add in Tlingit and Eyak. As I said, some cases you can see in a survey that no tonal languages are found in a particular language family. So Dravidian, Australian, Sepik, Quechuan, Turkic, Caravan, Salish, none of those languages are tonal. And there's a survey of the language family that tells you this information without looking into each individual language. On the other hand, some language families have a lot of tones. All Uto-Manguean languages, Mexico mostly, are tonal. All the Kra-Dai, that is Thai and its relatives, Hmong, Mian, and Lakes Plains languages are tonal. Lakes Plains is one of the Papuan language families. On the other hand, in Mayan, there are a couple of languages which are tonal. So only 6% of the language family is tonal. So altogether, I could find comprehensive lists or surveys for 21 of the 34 language families. The rest estimates are based on a sampling procedure. For example, calculate the percent of tonal languages in a sample and extend that percentage to the entire family. So the South African Phonological Inventory Database, of Michael and others, has entries for 45 Arawakan languages, and seven of these are tonal, so it's about 15.5%. The Ethnologue lists 55 languages in the family, so if we take that percentage and apply to 55, we get 8.6. So generous would call that 9. Since I don't know anybody speaks 0.6. Well, actually, so there's some somewhat rougher estimation procedures in some cases where we listed every language named for the family. Trans-New Guinea would be an example. There are a large number of languages in this family, but many of them are not at all well known or barely known at all. 123 of them are reported as tonal, 65 are reported as tonal, and the majority we don't know. It's 293 other languages. But if we take that percentage of those we do know the facts for, then we get about 34.6% and estimate 167 as the plausible percentage within the family. Similar procedures apply to 4 of the other Papuan language families, Dagestani and Chibcha. And then there's a sort of more mixed case for a language family like Afro-Asiatic. There are 6 major subgroups within this family. Egyptian, Semitic and Berber, non-tonal, except I hear that Sudanese Arabic might have a developing tone system, something I learned today from James. And then there are Cushitic, Omotic, and Chadic branches, which are partly tonal, have tones in well, the Chadic is almost entirely tonal. Cushitic and Omotic have minority tonal. So we have good general surveys of Semitic and Berber languages and not tonal. No overall surveys for the other 3 living groups. And so we had to go to an extrapolation from samples of those. It turns out that it's this kind of estimation that's required for most of the bigger language families. like Niger, Congo, Austronesian, Trans-New Guinea, as I already mentioned, Sino-Tibetan, a large number of little-known Sino-Tibetan languages south of China, and even within China, Afro-Asiatic, Bio-Saharan, Austroasiatic. So when we go through the survey as a whole, these are the percentages. The first column there is the number of languages in the family. The estimate in the second column is how many are tonal within that family, and then at the third column, whether this is based on a survey or an estimate. It's indicated. And there are 600, 5,020 languages, and about 47% are tonal. And this is trying to be careful to bias the sample towards including more tone languages. So languages that have a system that people might call pitch accent, that looks very stress-like. Japanese, for example, is counted as a tone language. Mm. So this is, if anything, perhaps likely to be an overestimate. In any case, it's well below that generally cited estimate of 60 to 70%. Tone languages seem, in fact, to be a minority of modern language, not the majority. Certainly make up a substantial proportion of current and recently spoken languages, but are not so predominant that we would be, from that fact alone, inclined to think that this was the default condition of any original human language. Which leads us to that other question: are tone languages the original condition of human speech? Stephen Brown asserted that was the case. We can't really know because we have not yet invented time travel. Mm-hmm. But comparative linguistics provides us with probably the best way to approach this, and there are certainly very important cues that we can derive. We can see from what we know about historical language changes whether loss of tone or introduction of tone is a more frequent process. And we can also look, bearing in mind that the suggestion was that lexical borrowing was the most important cause of the spread of complex tone systems by effort of our. We can certainly ask this question. So are tone languages original? In quite a few language families where there are no tonal languages and no documentation of tones existing at an earlier stage, there'd be no reason to construct tone as part of the original family. It's in families with some or all tonal languages that the comparative historical studies will provide the strong evidence for original tonality. And there are several language families now almost entirely tonal that are defined, that are definitely reconstructed as non-tonal, including Sino-Tibetan, which includes the most well-known tone language in the world, Mandarin, Kra-Dai, Thai and all its relatives, here, Athabascan, Austroasiatic, Hmong-Mien, and Hmong-Mien, Kra-Dai, all the languages are tone languages, but we know that they were not original. So what happens in so many of these languages is that features of flanking consonants get transferred into contrast within the nucleus of the syllable because of micro probably affects small differences in pitch, onset, offset. So this is well known in the history of Chinese and Middle Chinese. What used to be features of the abutting consonants get transferred into the nucleus, and we get the origin of what was originally a four-tone system at this period. And this is well documented because we have documents recording the properties of Chinese syllables dating back to the 7th century. They're broadly similar processes in Kardai, Hmong-Mien, and some Austro-Asiatic languages, just to cover a couple of those cases. In Vietnamese, very similar process to what happened in Chinese took place. What used to be voiced and voiceless onset consonants lost that distinction. Dominant final, stop final, fricative final consonants also lost much of the character of the consonant and transferred that, so the stops all get neutralized. Actually, no, they do in Chinese. But these processes are not always as complex as these very well-known and well-documented cases. So a different Austro-Asiatic language, Khmer, developed tone in some dialects, but not in all. And so the voiced onsets leave you with a low tone from the following syllable, and in the case of original voiceless onset consonant, you have a high tone. So this is a very simple process, which is also quite well documented in a variety of other languages. So there are actually only two families which it seems there's a reasonable likelihood that they were originally tone, but we can't find any evidence of tone being introduced by this kind of process. There's Ottomangian, graphed here, and Niger-Congo, which is over much of Central and Southern parts of Africa. Unfortunately, reconstruction in Niger-Congo has not gone very far. There are tones in virtually all of the modern Niger-Congo languages, not quite all, but a very large majority, and we don't know the origin. So we actually end up with four major language families, for which we really can't say Indo-European, although it's the best documented language family anywhere. The experts do not agree as to whether there was tone or not in the proto-language. Vast majority of modern Indo-European languages are not tonal. And my reading of the data is that Indo-European originally had a stress system, and that's supported by the fact that you get all these vowel upload processes where vowels appear and disappear, which suggests that the stress retain and lack of stress very disappear. Some languages don't do that sort of thing. Same is true for Afro-Asiatic, Maddieson, Trans-New Guinea. Really can't say at this point whether they were or were not originally tonal. In Indo-European, there are a few recently developed simple tone systems, or ancient descriptions that talk about high and low pitch contrasts. There are languages like Swedish and Serbo-Croatian with sort of tonal, semi-tonal systems, but no consensus on the original tonality. Afro-Asiatic is about 66% tonal. three major branches are not. Chadic is largely tonal, Cushitic and Nilotic mixed. Chris Ehret asserts that the northern branches, Semitic, Berber, and Egyptian, were tonal but lost it. Where's the evidence? No evidence, really. And we have ancient records for many of the Semitic branches, and of course, Egyptian as well. They give no hint that there was tone. There's some signs of consonant-induced tone in Chadic and conversion of stress to tone in Cushitic. So some hints that there may be tone introductions in the branches that are more tonal today. Nilo-Saharan, again, mostly tonal. The only attempted reconstruction at the family level is again by Chris Ehret. What he does is project the tone system of single language, Uruk, back to the proto-language. That's not sound comparative research. Some subgroups are non-tonal, so the thing is definitely up in the air. Trans-New Guinea, we just don't know enough about languages to attempt a reconstruction at this point. About 35% of the languages seem to be tonal, but where that tone came from, we don't know. But the comparative studies resumed overall show rather few families requiring an assumption of original tone. They're the ones with the answer yes in black versus those where the answer is no, which are by far the majority. So we have a clear data showing tonogenesis, the introduction of tone in the families that have it today. We have few cases where tonoexodus, loss of tone, is documented. And there's no clear example of widespread loss of tone in any of the families for which we have good documentation. There are individual languages like Swahili within Niger-Congo that had major contact with Arabic and lost tone through that process. But other cases where tone has been lost do not seem to be terribly frequent, except through this kind of contact process. So why is there the proposal of original tone? It's often because people who want to advance this idea think that language and music have a common origin. And people were chanting while they worked or whatever. So singing and language basically were not distinct activities. And that's kind of cute idea. I suspect also at the back of people's minds, although they don't ever write this down, is Homo sapiens originated in Africa. Most sub-Saharan African languages are tonal, so probably the original human language is tonal as well. And of course, that's not a scientific argument. So tone is not predominant, tone is not original, and the statements that claim so are simply assertions and not based on evidence. It doesn't mean to say that pitch didn't play some role in proto-language, but it was more likely to an intonation contour over holistic utterance rather than anything like lexical contrast. And that's just as compatible with the idea that music and language have a single common origin. It doesn't have to be a lexical distinction of tone to share the use of pitch variation, both in a more artistic way and a strictly communicative way. So presuming from earlier stages, what might favor this change from non-tonal to tonal status for a language or language family. And what I would suggest is that the use of tone is a way to optimize the slow modulation of speech signals, slow changes, since contrasts of tone are realized over longer durations, an entire vowel or an entire syllable. And slowly modulated signals are more faithfully transmitted if there's anything adverse in the environment affecting the way the signal is transmitted. If it's changing more rapidly, then the chances that you will hear faithfully what was originally produced will be less. And the two particular factors that affect the faithful transmission of acoustic signals that I think are relevant. One is higher ambient temperature, and the other is denser vegetation. There's a lot of very interesting work on bird songs that show in particular the effect of denser vegetation. And birds that live in denser vegetation use slowly changing songs, whereas birds that live in open environments typically have very rapid trilling, bigger changes in the signal over short time periods. And that was part of what started me thinking in this way. Now, why would this combination of factors be important? One thing is higher temperatures increase the atmospheric absorption of sound energy, primarily because of the frequency response of nitrogen, which is the dominant gas, the more frequent gas within the ordinary Earth atmosphere. And the properties of nitrogen are to absorb some of the energy, the physical energy of an acoustic wave. And critically, for high frequencies, the atmospheric absorption is usually much higher than the spreading losses, the simple loss of energy as a sound spreads, which produces about 6 dB for every doubling of the distance from the source. And then secondly, the presence of dense vegetation produces what's called scattering. The acoustic signal is broken up, is scattered. At high frequencies where the dimensions of leaves become comparable with the wavelength, there is also significant attenuations caused by scattering. Third thing, atmospheric turbulence. So temperature fluctuations, wind variation also disrupt both the phase, the coherence, and the amplitude, the actual energy strength of acoustic signals. The acoustic fluctuations are in some respects analogous to more familiar optical phenomena. So, example, so one easy way to visualize this turbulence is heat shimmer. Heat shimmer, in fact, affects both the optical and the acoustic paths of transmission. And shimmer is greater in hot conditions. The cumulative effect of these things is to weaken high frequency components and blur the timing of events. Previous work, this was with Christoph, had shown that languages in wetter and hotter areas tend to be less consonant heavy. They simplify the number and complexity of strings of consonants relative to languages in drier and cooler areas. So this is a plot of consonant density index versus mean annual precipitation and mean annual temperature. Well, precipitation to some extent is standing in for density vegetation. You don't have good precipitation, you don't have dense vegetation. And languages are also shown in another study, languages in areas with higher temperatures tend to have a higher proportion of sonorants, fewer of the consonants, particularly obstruent consonants that depend critically on high frequency spectra for their identification. So all this works leads in the same general direction. Languages spoken in hotter, wetter, more densely vegetated areas tend to use fewer consonants, especially obstruent consonants, and have simpler syllable structures. That is, they reduce the role of more rapidly changing aspects of spoken language and of contrasts that depend on higher frequency components for their recognition. This is likely because the listener is always playing a role in speech change, and if you don't hear some of the details of what someone has said, when you reproduce that, you will ignore the details that you didn't hear. This is O'Hara's suggestion. The role of the listener is playing a very important role in introducing speech changes. Just to give a little illustration, using English words. English allows very consonant-heavy structures, words like strict, with a cluster at the beginning and the end. It also allows very sonorous words like away. So if we play this, I hope it will. We don't have, of course, the sound connected in. Let's see if I can just do this. Away. Yes. Away. Strict. Okay. So you hear me saying strict and away. Away. Now, if you filter the high frequency information out of this, I did this in a very crude way by simply eliminating any frequency above 1000 hertz. You can no longer really recognize the first word. Whereas away is perfectly intelligible. So this is not a realistic simulation of what happens in high temperatures or dense vegetation, but it does give you an idea of how certain kinds of structures will survive severe degradation of the signal and still remain understandable, whereas other kinds of structures will be very difficult to understand, to repeat. So,
yeah,
you already said that, but you can read it. I forgot the way I structured that slide. And what is particularly important also to note, not only can you hear the segments in a way, but you can hear the pitch contour. The fundamental frequency survives even severe degradation of the signal, because fundamental frequency typically is changing fairly slowly. If it isn't, you don't perceive it as pitch. So I've been working with Carl, whose picture I showed at the beginning, where we're trying to deepen the examination of the relationships between various linguistic and environmental variables in this 1,000 language sample that was mentioned, where we tried to emphasize in the sampling of the 1,000 languages, geographical diversity. So we made particular efforts to, for example, get languages that are spoken in deserts or are spoken at very high elevations, like on the Tibetan Plateau, or are spoken in the Arctic regions of the Northern Hemisphere. And what we found at this point is that there really is no relationship between different levels of tonal complexity and this humidity variable that was put forward by Everett et al. And you can see that although there's a fairly wide scatter for languages with no tone, they are found in the Arctic regions, for example, and simple tone and complex tone. There's no statistical difference between these distributions. We do find some association between temperature and greater tonal complexity. So the more complex tone systems, the purple on the right-hand side there, significantly have a mean annual temperature significantly higher than those more simple tone systems. This is still something we're very much working on, and part of the reason why we have this is the big contrast. Part of the reason we have some hesitation about putting forward this is because we have, to some extent, shot ourselves in the foot by limiting our data to a period of relative stability in global temperatures between 1950 and 1980, and relying on Earth-based weather station data for this. Unfortunately, in rather large parts of the world for which there are no reliable ground-based weather station data available from the 1950s to 1980. There's very little in Africa in particular, not very much in South America. Brazil's not bad. Most of the rest is and very sporadic coverage in the Indian subcontinent and much of East Asia. So we're missing crucial information from the areas where tone language is most frequently spoken, unfortunately. So we're trying to find a better way to estimate that there are excellent satellite-based data on current temperatures or very recent temperatures, but satellites were not doing this data gathering in 1950 or 1960 or 1970. So we're trying to find some way to get a projection back to 1960-ish conditions based on more recent data. That's work in progress. But one thing we do note is that tone languages tend to also have larger vowel inflections. Again, a signal that emphasizing the use of these slow changing acoustic properties. So we've got the mean number of vowels overall in the language in blue, and as the tonal complexity increases, you can see that the average number of vowels increases overall. That's including nasalized long vowels, pharyngalized vowels, whatever. And on the bottom, there's the table of the values of the basic vowel qualities. So abstracting away from these other kinds of contrast, just the frontness, backness, height, and rounding properties of the vowel system. And again, the same trend towards more complex vowel systems is found as the complexity of the tone system increases. So this suggests this drive towards greater overall sonority in tone languages, which is more robust to adverse transmission conditions. So we suggest that tone is not original in language, but has a higher probability to develop where acoustic transmission is degraded. And it's this which explains, at least in part, the distribution of tonality in warmer areas, but not in deserts, because you don't have the second factor which I think is important, which is the vegetation issue. And that's where we are at the moment. Stay tuned for further analysis. And thank you very much for your attention.